Good morning, all. Welcome to lecture number 5 for the analysis and design of high-rise RCC buildings online course. Today, the session subject is modeling and analysis in ETABS software. So we will go through the detailed uh, method in which the models are created in ETABS software. In the last session, we had seen what are the manuals of ETABS, how we can refer those manuals and use them to our advantage, and check whether the Indian standards are completely being followed or not followed, because that is the job of the structural engineer to check whatever the code outcome is there is code compliant or not a code compliant for each of the elements like slab, beam, columns, and then there is retaining wall, then shear wall. So all those clauses have to be checked. In the Indian standard, there are no plain shear walls considered. So we can refer the analysis of plain shear walls from ACI code. That very well explains how to analyze or find the PMM curve for the plain shear walls. So plain shear walls are the walls having a web and top and bottom flanges, and that would be what we say C type or T type, L type, F type. All those shear walls are called the flanged shear walls. So that design has to be seen from the ACI code. And rectangular shear wall analysis or the design is given in IS 13920. So once we are through with ETABS, we will also go into particular element design. Once we are thorough with the analysis manual method, then analysis software method, and let's say behavioral assessment, which is dynamics part, which is the next session, structural dynamics. And once we are through with that, then we'll finally go to the design segment of it, each element design. Okay, going ahead, I will start sharing the model for today's session. How we are going to model everything in ETABS today. Hope my screen is visible to you. So once you click on the ETABS tool, uh, this button, this page will open in front of you. And this is the new model that I am creating right now. Or I can open an existing model from this option. So once I click on the new model, it will ask me for the unit system that to be used. So SI unit and materials are based on Indian. Section database is Indian, IS 800 2007 and IS 456 2000. So once we are writing all these things, we have to also ensure the things are the outcomes are also similar. So while reading through the ETABS manual, as explained last time, for each part, that is analysis and design, you can check how the software is working and how the outcomes are being generated. So that is transparency of the software has to be evaluated before using it. So last time I had shown you that there is a custom grid spacing option, and there is a option that is directly available template. This is the quick template in which if the wave spacing is equal, you can use this template. If you want a custom spacing, you have to use this template. Uh, Let me show you one example. This is the building model I want you to generate in your ETABS for this course. Okay. There is no shear wall in this building. These are all the columns. And this is a column beam system for the lift shaft as well. So Spacing you can decide based on your requirement, what will be the spacing and all those things. Or I can share you the AutoCAD file of this. From that, you can find the spacing of the columns wherever it is there. So this is the detailing good for construction drawings of this project, which is 15-story building. So I can either you can assume the data and generate the model of something like this, or you can use the this we say AutoCAD file to generate it. So first thing I would like to show you is that this is the total plot layout in which there is a podium. This entire thing is a podium where the shops are there, and here on this side where you are looking at the lift shaft, two buildings are there, 15-story building, and this is total complete podium is there. So building is up to uh, this particular limit. So that way you will have to generate the model. So without the podium, that is the first thing you will generate if you want to make the arrangement more complex for analysis design. So this is the building limit to model. Just for reference, I have shown to you. Now you can see the size of the columns are given here. Thickness of the slabs are also given. And there is a grid spacing. Now all these grid spacing you have to enter in the software, but which grid spacing you will put in the software, that is critical. So we have to always follow one is the uh, beam center line. So beam center line has to be modeled in the software. So what distance you will model between this column and this column is the beam center line. And when you will put the column at this position, you will give the offset. So your modeling has to be as per the beam center line. So considering that, you have to estimate the grid spacing, and then you have to generate model, which is something like this for this building. And all this has to be beam center line. Right, so this B15, B18, so center of these beams, you have to create the model. So all beam center line has to be used to generate the grid spacing in your software. So once you go through this model in detail for each floor, so this is 9 floor and 10 floor plan. The name is written, and column numbering is given and beam number is given. So based on that, you will be able to create this particular model. And also the ETABS file is also there for this model. Sorry, not ETABS. This AutoCAD file is also there for this model, which I can share with you. This is the raft foundation. Complete raft is there, which you can design in safe software, this particular raft. And these are the various columns. And this is also a column beam system for the lift that you can model and design this raft. Here are the reinforcement details of the raft given. Column details is also given. You can validate your design with respect to this results. This is a completed project and it's been done quite 3-4 years back. So it is already on ground. So general detailing how it is to be done for a routine project, a residential project. not a very big, luxury project. So all these good details are produced by the structural engineer that has made this particular project. So this is the lift section in which the lift pit will come. So lift pit is there and the uh, perimeter RCC wall, the reinforcement is provided like this. So these are the beam details. All reinforcement details are also available with you. So column details floor wise, beam detail floor wise, staircase details, everything is available with you to model it and go ahead with the design. So this is the foundation layout, entire foundation layout. You can see it here how it is made. So group of footings has been created like this. This is the trapezoidal footing, sloped footing basically. These I have uploaded in the software, this uploaded in MS Teams. I'll just show you where I have uploaded it. So once you go into the file section, 15-story RC frame building plans, I uploaded the images uh, into this. So you can refer these images and start modeling for the 15-story building. So going ahead, either you can use this option of custom grid for real projects that we have. Okay. There is another option in which you can directly export the uh, this CAD file spacing into the ETABS, and that also you can do it floor wise. However, generating anything in ETABS is very easy, so I don't go by that method. I actually model it by giving the spacing manually into all these options because it is not taking that much time. If you have all details with you, you can easily put in half an hour and you can create a grid for any project. So right now I am using custom grid spacing. So in X direction, I will have 5 bays, Y direction, let's say 4 bays are there. Uh, X direction, I will keep 7 meter spacing. Y direction, I will keep 5 meter spacing. Number of stories, let's say I'll take 10. Typical story height 3 and below story height I will take as 4 meter. Okay. So 3.1 is generally what is the story height preferable, not less than that. But many people have 2.8 or let's say 2.9 story height as well. Uh, However, 3.1 gives good head space to the occupants, but that also depends on the builder. Here also you have the option to, increase or decrease the story. If you want to add more basements, you can just add a story. So keep existing story height and add one story here. So story height is of, let's say, 3 meter for basement is very less, at least for the basement which is at the near the ground level. It should be round about 4 meters. So I'm taking as 3.2 meter. So insert above story, that is base. replicate new story from existing story, which is 1. So story 11 got added here, so I will take it as basement 2, and I'll also add a basement more if I want to add one more basement. This I will take as 4-meter story height. This is the basement 1. So this story 1 up to 10. So this I will take as terrace. Here you can give also the elevation level. What is the elevation? If my this is 4, so if this elevation level is 36 meter, either it will directly come to you or you can just check. So this way the elevation can be seen for this building. It is around about 40-meter height. Okay, and master story is the terrace level, and these all stories are of the similar nature because they are of 3.1-meter height. This is 4 meter, which is not similar to that. So I can say this is not similar to terrace, so that when I select the similar stories, basement will not be selected. So up to story 1, all similar stories are there, and this is none. This is not as terrace. So this way, you can generate your building data, or you can only you can give from the simple story data or a custom story data. Based on that, the building but will get generated. Now you have to choose what you have to do in structural objects, whether it is a steel deck, staggered truss, flat slab option, perimeter slab with perimeter beam with flat slab. This is the more common option in the metro cities for high-rise buildings right now. Waffle slab, very limited use, two-way or rib slab. So uh, we generally go with the grid only option, or we can go with the flat slab with perimeter beams, or in grid only we can generate such arrangement. So there will be a central core and flat slab system, and perimeter beams will be there to combine the columns with the core on the perimeter. And in between columns will be all gravity columns. So here you can see this particular story. There are only 4 stories created, as we had clicked it in a different way. So those stories are not generated. So by mistake, story has not generated. So what I can do is go to edit, and I can go to edit story data, and I can do the same thing here. So I can just keep on adding up to let's say 3 meter, and 4 stories are there. So I will add 6 number of stories above. So 10 stories it has generated. Now I had kept 3.1. Now it is 3 meter. So I'll have to again, do 3.1 everywhere. Or I can go to dot set file and make it that way. Control C, Control V you can use, or you can go to the editor file and make it that way. So this is 4 meter that I had done. 2 basements also I had added, so that also you can add. And You can see a master story here. Every story becomes a master story here. Previously, it was not the case. I'm just editing like this. So terrace story is the master story, and this is similar to 10. Or you can select it is not similar to anything. So I have refreshed the view. Now I have the grid system. Here you can see if I make the spacing 777 in X direction, 555 in Y direction. Now this also I can edit or do anything I want. So overall you can see 7, 4, 28 meters and 5, 15. 28 meter by 15 meter the building has been generated. Now I can create a reference point or I can create a reference plane. So in Z direction, the height is 3.1 meters, so half is 1.5. So I will take 1.55 meter. This is for the staircase landing beam. Okay. So staircase landing beam, I have to model. So this level has to also be generated. Now this has to be at every floor, right? So 1.55 plus the floor height is 3.1, right? 4.65 is the same staircase ID. So all those floors, I have to generate staircase. Same way I can do it, or what I will do is I can create a beam here and I can just replicate it all other places. So I will not generate anything else except the first level. So reference plane I have generated to model the staircase. Same way Mumty slab reference plane you have to create so you can model the Mumty level. Reference points where the in between points are there, like the slab on which you want to give the load of the wall in the center. There you cannot give uh, directly the load of the wall in center of the slab, but because that option is not available. So you have to generate reference points and between those points you can apply the loading on the slab in center or at any position you want to apply the loading, except at the perimeter or the full area. So a line load at center of the slab cannot be applied uh, until there is a grid or a reference point. So at that positions, you can generate the reference points or you can generate a reference grid in plan. Now there is another option of the origin that X direction, Y direction, what is the centroid of this XY position. So your axis position can be either 0, 0. As you can see in this model, the 0, 0 is at this point. You can shift this XY 0, 0 position to any coordinate position that you want to take it. So only the XY will shift, modeling remains the same. And same way you need to check because once your 0, 0 position is changing, plus and minus directions will come. Right now it is 0, 0, so we are maintaining it to be 0, 0. Now rotation angle, if I put it as 45 degree and I make it okay, so you can see that your building orientation has changed to 45-degree angle, right? So once you are doing, hmm, so this is how your model will look like this way. Your X, Y is 0, 0 positioned here only. However, building is modeled at 45-degree angle to X1. So once we are through with this option of editing the stories and grid system, there is one more option. You can add a new grid system. That is, you can generate a new building beside it, or you can create a larger podium beside it, and you can also create circular arrangement beside it if the grids are different. So here you can see either it is a Cartesian system, that is a rectangular grid, or it is a cylindrical system, that is a circular grid, whatever you want to create. The origin you have to give again for this, you have to align both the grids at whatever angle you want it to. Number of grid lines in R direction, that is on the radius. Tangent, that means on the perimeter, how many number of columns are there. Spacing in the R direction, that is radial direction, what is the spacing, and spacing in the T direction, what is the degree. So in form of the degree you have to give. So columns are oriented at 30-degree or 20-degree or 45-degree. Based on that, you can make a circular grid. You can change from AB to the 1, 2, 3. You can separate the grid naming and select whatever the grid you want to generate, and at what origin point it has to be generated. So even multiple grids can be added here. So once you are through with the grid system, now we can do the modeling. Now only problem is that when it is a 45-degree angle, all your building elements have to be modeled at 45-degree angle. So better what you can do, you can change it for now to 0-degree. And first we'll model everything, and then you can also rotate. But once you rotate the grid, that does not mean the element is also rotated. So you have to be very sure when you are modeling, if you want to model as a rotated arrangement, you rotate the grid and also the element while modeling from initial level itself, not later on. First, I will save the model. Now, once the grids are created, now I have to, you know, uh, all these options you can see later on, how editing, replication, mirroring, that all option is available. Copy and move options are also available. I'll now go to view option. In view, there are various views that you can see: the plan view, 3D view, elevation view, and display options, uh, partial zoom, zoom in, zoom out, walkthrough, how to measure the line, measure angle, measure the area option is there. Grid visibility, if I select this, my grid is not visible here. Again, I select this, the grid is visible. So Control D for the grid. Show axis. If I select XY axis is gone. If I click again show axis, then XY axis will come. Change axis location, that is changing the XY position. If I make it 1 and 1, and let's say, yeah, then XY will shift to from its 0, 0 position to any other position, right? So I'll again bring it to 0, 0. Now, other options are there, like when you right click on this window, add or modify grid, locks on screen grid system, set grid visibility, show selected objects only, hide selected objects. Now restore visibility of previous selection, show all objects, snap options. Snap options, you have to click midpoint, line ends. intersections, then parallels. So minimum this much is needed to model it properly. So you have to select the snap option. Draw using snap only option is there. Graphic preferences, that how the screen will look like. My height of the text is 8 for a maximum, and minimum is 3. It is Arial. I can change it to any other display also. Quality, screen line thickness, printer line thickness, shading within the element, auto zoom step. What will be the percentage of zoom while you scroll? Okay, automatic 10% will increase. Shrink line object 70%. So this way the default settings are available. By right clicking, you will get all these options. And this is are the toolboxes. So this is the new model. This is open existing model, save, undo, redo. This is refresh the window, lock the model, run analysis. This is rubber band zoom. This is restore full view. This would be restore previous zoom, then zoom in one step, then zoom out in one step. Pan option. This is walkthrough 3D plan elevation. This is the rotation, which works only in 3D arrangement. So you can select and rotate the model. This is the perspective toggle. You can go in and out of the building. How much you can limit by this perspective toggle. Object shrink toggle, that is very less used. This is means set display options is critical. What you want to display, so that you can tick from here. Now in the reinforcement, layer A, layer B has to be ticked, and section properties if you want to see, material properties if you want to see, groups you want to see, then what we say stories if you want to see. So every story will look in a different color by selecting this option. So by default it is the objects. Now object assignment, you want to see the section of that object, property modifier, and releases. All those for the joint assignment, frame assignment, and shell assignment is available here. And other assignments also, what is the peer assignment, spandrel, design strip for the slabs, link elements, tendon objects, then slab rebar option. So all this is available. So whatever you want to see on the screen, that is what is available in the set display options, control W. Okay. Now this is the extrude view that will convert your line element model into a 3D model. Each element will convert into a 3D object. Then this is the undeformed shape. So if you are looking at a model in with the shear force bending moment diagram is there, reinforcement percentage is there, anything option in which you have seen some outcome into that, you want to again come to the normal state, you can select this object, this option, that is show the undeformed shape, F4, either click F4 or click this option. Now whatever the loading you have applied as joint load, you can see from here, UDL load from here, area load from here. And after the analysis is run, all these options are available. So deform state, reactions, then this is soil pressures, SFD, PMD, then shell stresses, then your strip forces for the slab and diaphragm forces. And these are the design options. This is the steel design option, concrete design option for the slab, sorry, for the beam and column only. This is composite beam design. This is the composite column design. This is steel joist beam design. Now this is the shear wall design for the plain shear wall and also for the rectangular shear wall. Now this is the slab design. So these are all design options. Once analysis is done, you can select this option, give your preferences, and after that you can see the design results. Now this is all the top bar you could see. Now this is if I have by mistake, you know, click this option and only one window is available, I can open by this arrow, add new window, and again this window can come. I can add more windows into this, or I can also close this window. This an update is available, so update can be downloaded from this option. Now these are the draw tools and selection tools. This is for the beam. Point to point modeling. This is the for the beam, that is the object, full object modeling in one click. Column modeling. Then this is quick draw secondary beams. Cross bracing. This is for the slab point to point. This is for the slab, you know, if the geometry is not rectangular, you can use these options. If it is rectangular, you can directly click between the grids and create it. This is the draw wall option for the shear walls. Quick draw walls, then wall with opening. This is links, drawing the link. This is the quick draw wall template in which different type of walls you can model just by clicking that option. A rectangle, this is the flanged shear wall. Top is the flange, in between is the web, C-type wall. I, then double C, F, and this is L-type wall. This is again a box type arrangement. So here the number of lifts can also come in this direction. So whatever is your arrangement, based on that you can select the shear wall. So design strips in this, if you want to make the strip yourself, that is the column strip and the you know in a middle strip, if you want to generate, how you will you can generate it manually, or the software will do it for you. So drawing the PT tendons, then draw the slab rebar. So all these options are available if you want to use it. However, software is automatically doing it as well. So I hope I mean some basic information which I am trying to share is through with you. So any query till now?
No, sir.
So this much basic information we should have for the ETABS software. Which version we are using is 21.2.0. Also in help, you can select that options and check. So watch and learn option is there. Check for update about ETABS. All this you should understand documentation. And these are the graphic colors in which the display option is available. So column, you can change the color to any type you want. And also your background can be white background or black background. Okay. So this way also it is there. And so this is the draw and select tool. This is all, geometry, display, analysis run, uh, floor If I want to go the below floor, so move down list. So I will go to floor number 9. I will get the elevation also. Floor number 8, floor number 7. So this way plus minus the floors we can reach to the terrace level. This is the 10th floor. And you can draw above OHT level also, like overhead tank. So above this, you can model overhead tank arrangement. And also there may be some, let's say, small terrace also here, and above which some solar panels are there. So all those things you can model above terrace. So once we are through with the basic arrangement geometry options that is available, we can go to define option. So materials by default Fe345 M30415 is already given. So either I can double click and edit M30. Okay, whatever I want it to be. Right now it is concrete. So concrete, it is isotropic. Density is given, E value, U value, everything is given. 30 MPa, M30. So modify oblique show material properties, design data, you have to give the strength here, whatever it is. And if you want to do some time dependent property like temperature and shrinkage, creep, all those things you want to include. So creep and shrinkage, you can include it from here. FIB model code is used generally, and ACI code is also there. And so you can choose your code, what you want to apply, and give the parameter for creep and shrinkage. In that also, drillet series or the full integration, how you want to, do this particular analysis. You have to give the number of days, notional size is important for this, age of loading, when it is starting, shrinkage strain, nominal size, size is 300 mm. All these are important parameters that you get from the FIB code. Right now, there is no creep and shrinkage effect for high-rise buildings, which are, tall buildings more than, 30 stories. You can, let's say more than 20 stories also, you can give these properties, not for this type of buildings. So material damping, so this is a high, when once you go in more detailed parameters, non-linear analysis, then only this data is useful to you. So if you are doing performance-based design, then in that case, these parameters are critical to enter. Mender model for confined concrete. You can convert it to a user-defined model. And energy degradation factor you can add. Ignore tension acceptance criteria, that is no tension in concrete. We can see the stress strain plot if it is not as per the mark, because you can see IOLSCP is gone beyond. So IU has to be here, LS has to be here, CP has to be here. So you see the values and then update these parameters where you have to keep it to see it in the graph of M30 grade concrete. Okay. So this way, these things can be updated. This is M30 FE415. If I want it to be FE500D, so same, it has to be defined as a rebar, not as a steel. Okay, it is a rebar. Reinforcement is rebar. Then its density, E value, properties you have to add. So it has to be have a minimum yield strength of 500, right? So how much will be the yield strength of this, and how much will be the ultimate strength of this? So how much is the ultimate strength of IP 500G grade? Do you know that what parameter should we put here? So if I make it 500 into 1.25, it is 625. So is this correct or not correct? So as per our IS code, what is the ultimate limit we have to take with respect to yield? So it is 1.15, so 575 is okay. In this, if you are doing the performance-based design, then you have to fill these values as per the real data. There is the general information for reinforcement, exact data of that yield strength. It may be 525 in reality, and this may be 600 in reality. So that way you have to update accordingly. When you do nonlinear analysis, then only these two parameters will be considered. In linear analysis, only this will be considered. Okay. So we have modeled this now for structural steel Fe345. Right now 350 is only available in the market. So that way 350 is the strength we are using. So this is also 350 or 345. So this way the materials are now defined. Once you define with the materials, go to section properties, and either you can import new properties or you add a new property. Now it is a concrete. There are various options: steel double channel, steel tube, steel pipe, filled steel tube, filled steel pipe, joist section, steel plate, steel rod, castellated beam, cellular beams in steel, concrete rectangular, trapezoid circular, encasement rectangle, encasement circle, precast I, precast concrete T section, concrete L section, concrete cross section, box section, pipe section, cold form C, Z, with hat, buckling restraint BRB braces, general section, non-prismatic sections. Non-prismatic section is that the depth is varying with length. Auto select option is there, in which you can give a software for choices, which is the best suited. The software will select automatically. Now there is SD section designer. You can make your own sections. So now if I select, so all these things are given here also. As you can see, this is the concrete rectangle, then circle. This is T section, then precast concrete I section, section designer, non-prismatic, auto select list, and general. And for steel also the options are given here. I will select the rectangle concrete, and let's say if I am giving it C1. So each floor I can define it separately, or what I can do, I can group. I can say first three floors, my column size is same, grade is also same. For construction, it is needed at least three grids. You have to keep the same. So for three grids, I will keep as column C1. Then I can write as C1 in bracket. I can write as 1, 2, 3 floors. Okay, or whatever you want to create for yourself. C1 is for 1 to 3 floors. That way you can create the sections that way. Now I'm 30 grade concrete. This is the color rectangle. Now I have to give the size. Now what should be the column size for a building which is 10-story high? So how much would be the size of the column? So right now I'll take 1200 and the thickness I'll take as 450. So what should be the height by the minimum dimension ratio to term it as a column or a shear wall? You have to check in IS 1893 13920 that in 13920 also it is mentioned that what is a column and what is a shear wall. So height upon minimum base dimension has to be uh, less than 4 to term it as a column. So height is 3100 divided by 450. So I can do it here also. It is 6.88. So what is the criteria to call it as a column and a shear wall? Anything that you can recall? Anything that you can recall? Aspect ratio? Anyone who can answer? Aspect ratio. It's given in the IS code.
1.5, I guess.
No, it's 4 times. So column is a member for which the section depth does not exceed 4 times its width, and height is at least 3 times the section depth. Okay, so that is considered as a column. In IS code, it is in a different way. So if I take it 1200 divided by 450, then it is less than 4, right? Now, if it was 3000 divided by 450, then it is a shear wall. Okay, so this is a column because 1200 by 450 is not becoming slender in one direction. So if it is more than 4, then it is considered as slender. In tall buildings also, that is the criteria. That is the aspect ratio in plan divided by its height. We can say whether the building is slender or not slender or tall or not. So aspect ratio is critical. So depth upon thickness, it is a column. Now PM to M3, which is a column option. If I select this will become a beam. So column selected. Longitudinal bars, you have to select the grade of steel, rebar. It is a circular column or a rectangular column, you have to choose. Reinforcement is to be checked or reinforcement is to be designed. That also you have to check. Choose that particular option. If you are want to check the reinforcement, you have to give it correctly all the options here. So reinforcement to be designed is the option selected. Cover is taken as 40 mm. Then diameter of the bar, all these parameters is irrelevant if you are designing it. If you are checking it, then these all things become very relevant. So once you select this option, this column, you can see the arrangement in which 3 direction is the major direction, 2 direction is the minor direction. You have to remember 2 is the minor direction, 3 is the major direction, and 1 is the longitudinal direction. So axial direction is 1, major direction is 3, minor direction is 2. Now if I rotate it like this, 450 by 1200, then your 2 is the major direction, 3 is the minor direction. And also you can see the reinforcement distribution here, which you had given in this particular arrangement is this way. However, this is not relevant if you are designing it. For checking it, this also is relevant. So how you are going to model it is very important. And your local axis and global axis. Two different things are there. They may be the same for some elements, they may not be the same for some elements. So you can say this is the local Z direction, 3 is the local Z direction, 2 is the local Y direction, and X is the local longitudinal direction. So this is Y, this is sorry, this is Z, this is Y, and vertical is X. So 2 is Y, 3 is Z. Z is the major axis. This is the local axis I am talking. Now global axis, you can see X, Y, Z is there on your screen of the software, which is red and green. X is red, Y is green, and Z is blue, vertical axis. So global axis and local axis, two different axes are there. Now all section parameters you can see. Now this, J, polar moment of inertia. This you cannot get directly, like for circular section, Ix plus Iy becomes polar moment of inertia. So if you do, J33 plus J22, you will not get J polar moment of inertia. For that, there is a formula in Wikipedia that you can refer. From that, you can get this answer. So when you are doing manual analysis, you will not be able to get Ix plus Iy as polar moment of inertia that we get for circular sections. So for rectangular sections, the formula is given in Wikipedia as well. So you have to go through that. In AB ratio is given. From that, you will get the polar moment of inertia. Now I can change the modifiers here, but I will not do that. I will do it later. So column naming, its size and parameters are defined for column. Rest other properties I will delete. So see the column 1, I can add a copy of the property. If I want to make it a column 2, and I want to now do it above the third floor, I want to change the grade. So I'll have to add a grade here. What I can do, add new material, concrete, Indian M30. I can take M25. or whatever is specific to me, I will take that. So directly everything will come to this thing, M25. So, okay, so this is M25 option is available to me. So I will take up to 6 story M30. Above that 4 stories, I will take as M25. Now size of the column, I am not changing. I am only changing the grade. Steel also I will change, but I am not changing the column size here. Orientation also I am keeping the same. And all those things are the same for parameters. So I of the concrete is not changing, but reinforcement and grain, that is the strength is going to change. So stiffness is not changing, but strength is changing. So now I will add for the beam, rectangular beam again. So B1, right now I'm taking up to all 3 stories M30 beam grade, and beam 7 meter direction is there. So my thumb rule says 700 as minimum depth. Okay, so I will take as 700 as the minimum depth, and width I will take it as 250, and I will change it to beam. Then if you have the right information of reinforcement available, you can give here for performance based design. However, right now you don't have any data, so keep it as 000. Grade of rebar, cover top and bottom up to center of the reinforcement. The cover is taken up to center of the reinforcement. Then yeah, rest things are the same. So B1, I'll copy of this property. This will be B2. I will make it M25. Rest things are the same. So my beams and columns, right now I have done the minimum arrangement. You can do it at your own wish. So frame sections I have defined. Now I will define the slab section. I don't need a plank, so I will delete the plank. One minute. Yeah, so this is the slab option we need to modify. So I'll click the modify button. So I'll take it as 125 as minimum slab thickness. Grade I will take M30 up to 6 stories. I am taking a thin shell. So I have to modify the directions. Okay, so 0.25 for strength case as per ACI code. 0.25 we are taking for ultimate. As per IS 1893, it is 0.3435 for service cases. So you can take it as 0.35 as well. But generally people are taking as 0.25 for ultimate case. So F11 is in the X in plane direction, so I'm not reducing the in plane stiffness. Other direction in plane stiffness, I'm not reducing. This is the what we say the complementary shear that is generated That also stiffness is not gone, only the bending stiffness reduction I am doing it. So once you go with so I have this session on shell and membrane, which I uploaded on the YouTube channel. You go through that also. Okay. So property note, display color, all those things I can change. And thickness I have to give as 125. This is either a drop of the this flat slab, or it is a waffle slab, or it is a matte foundation, or it is a footing, or it is a ribbed slab. So whatever the option is there, you have to choose. So I'm showing if footing is there, mat is there, this also will be used. Right now it is a slab, so 125 RCC slab we have defined it. Now add copy of the property. Again M25 but floor wise I will add from 7 to 10 upper floors. I'll change the properties, rest all things remain the same. 125 thickness, okay. And once this slab section is defined, I can define it other zones separately. So now I will start modeling. Now there are two things right now I'm not considering while I'm modeling, is the position of the staircase, position of the lift shaft, and service shaft. So all those things I'm not considering. So wherever somewhere there will be a lift, somewhere there will be a staircase. So whenever there is a lift, now you should ensure either on all four sides the columns are available for smaller height building. For bigger height building in high seismic zone, it should be enclosed within the shear wall. So if you see between this BC and 2-3, if the your lift is between these four corners, okay. So all this should be covered by shear wall, enclosed by shear wall. So staircase enclosed within the shear wall or attached to the shear wall. It should not be open, otherwise you will have to model the staircase and show it is safe under the earthquake forces. Okay, so enclosure within the lateral force resisting elements is necessary to protect the shear wall from the shear effects of the earthquake. Okay, so now I can take this option. I can draw any element, frame element C1, C2, B1, B2, whatever I want. It is a continuous element or it is a pinned element, like two edges are not fixed, then I will take it as pinned, or either continuous. Offset, plan offset I have to give from here. So mostly in all columns you have to give offset because the framing is done center line of the beams. So your grids are with respect to beam center line. Then your this plan offset for the columns will come if they are of such large size. Now draw line type with whether it is a straight line or whether it is a arc between 2 points, multilinear, spline, center and 2 points. So all these things are also possible using this option. Now drawing the control point. Now what is my control point to draw? Right now there is none. So fixed dx and dy if I choose, so I have to give a distance in which my point will be, like I'm choosing this, but it will be modeled somewhere else. So drawing control type, fixed distance, fixed length, then fixed length and angle parallel to angle A. So only in that particular angle the model will be done, parallel to X, parallel to Y, or right now it is none option. Okay, so this is the first option. So I have to click the points from where to where I have to model using this particular first option. Right. So what is this option? Plan, elevation, and 3D. You can model anywhere. Now, as I want to draw between grid to grid, so I will select this option, quick draw beam column. Okay. And I will draw the beam like this. See, if I select, beam will be drawn. So what I am doing right now, I am first drawing the columns. So this is the quick draw column option, and this is the C1. Now how I want to model this is also available. Bottom left. So right now I am picking the center of the column, as you can see. To model, I can also click other points to model as well. So this option is available. 10 options are there to model the column from which point I want to model it. Right now I'm choosing the center. Other may do it in a different way also. So as per requirement in the plan, bottom left, bottom center, middle left. So I will model middle left. So it will be model somewhere like this. So you can see it is off center model created. So let me choose this option, and if I select all stories on this plane, angle is 0, plan offset is 0 in X and Y direction, middle object it is modeled. I am drawing using the grids, and if I select this everything like this, then the column will be automatically generated in all stories, as you can see in this 3D extruded view. So extruded means I can see the all columns that are generated in 3D. Or if I select only one story, then I can select this column. Now this is the story 10. So I will take the C2. I will take middle center. And I will select this for this particular story only. So you can see only on the top story, these columns are generated. Now what I can do, I can do escape, come out of it. Now I will select these columns. I will go to replicate option. I will select the stories 987. Okay, I don't want to delete the original object. You can see the column C2 is generated. Now I will go to plan. I will go to story 1. Again, I will create a column. This column will be C1. Continuous, not pinned. All this is there. And only one story is selected. So I will model the C1 columns. Select it. Now edit, replicate two stories, that is 2, 3, 4, 5, 6. So this is how you can see that once you right click it, you will see this is C1, and the C1 has grade M30. This is C2, it is M25. So this way how you can create different models per floor. Now this is story 1. Again my beam I have to model. So I will take B1. Again it is a frame B1. Now I can have a frame also, or many things opening also. So all those things we will see later. So B1 is my beam. For one floor, I will model the beams. So what I can do, either I can model the column and beam together and then replicate it as a whole, or what I can do is I go to select object type. I have model beam only ground floor, right? So this is I will select as ground floor beam is selected. Now replicate it for the story 2, 3, 4, 5, 6. And I can again go to plan at the terrace level, make the model for the beam B2 created. Now I can select again the object type as beams, select, close. Now select what I want to deselect it from the stories. So from all other stories, you deselect the beams. Only my top story beams are selected, below beams are not selected. So now I can edit, replicate for 7, 8, 9 stories. I apply. Okay. So here once I right click it, this is beam B2. Here it is beam B1. Okay. So you can also do something like this. Okay, maybe from here also you can do stories and then you click OK. You can see different stories, the different colors are generated like this. However, the top story, the same color has been selected. That's why it is showing in same color. However, in normal cases, it is all different colors you can see in the stories. So actually we replicated it. That's why it is not showing that particular way. So either you can do like this, or what you can do is if this option is not working in that particular direction, you can go to options and take columns and beams like this. So that will be more clear to you later on. And also you can change the section, C1 and C2. So I want it to be of this color, C1, and C2. I want to see in a different color. That may be, let's say, pink color. So that you can see how you can see the object instead of section properties. Also, you can see this way. So as I chose for the section properties differently, so this many floors are C1, this many floors are C2. So this also used to check whether you have modeled it correctly or not correctly. So up to 6 stories, the beam colors are different. B1 and B2 are also different. That is clearly visible on this arrangement. And here the different color is available, which I had chosen for column and beams. So this way you can create different things to check your modeling. Now I am going to model the slab. Yeah. So this option is for point-to-point modeling of the slab. So I have to select 4 points to generate it. So this is showing as a deck. However, I have to model this floor is 10th floor, 7 to 10 option. Local axis 0, straight line, or whatever the spline multiple are, you have to choose. Now control point also you have to choose, or you have to select as opening. So if I select this much portion, it will become an opening. Okay. So if my staircase is coming at this particular portion, so I will model that area as opening. So 7 to 10, I have selected it, and this is the 10th floor. So I will select this particular option. This is not going to work that way. This is point to point. Now this is your again you have to select the points like this to create this floor, but it will be fully rectangle. This has option of different type of arrangement. This is rectangle arrangement, point to point. So best choice is this. So 125, 10 to 7, one floor is selected. So this floor is now modeled. Okay. So I can select object type. It is floors. Now floors are selected. Now replicate it to stories 897. You can see top four floors are modeled. Now again, I will go to story 1. So either I can select like this, or I can again go there and select it floor wise, replicate it 2 to 6. So you can see 1, 2, 3, 4, then 1, 2, 3, 4, 5, 6. This way differently the modeling has been done. So this full area is M25, this full area is M20, M30. So you don't have to do puddling during construction. To understand puddling, you have to refer ACI 318, and it takes a bit more time to construct in puddling. So there is a grade variation between column, beam, and the floor. Then you have to wait for puddling. So if we have kept different type of grades in a medium rise building, then it may be higher time. Maybe for very high rise building where the column grades are changing very significantly, like M60's column, your floor cannot be M60, it will be M30 at the most. Or shear wall is M60, your floor cannot be M60, your beam not required to be M60. So that way, in those cases, you have to do the puddling during construction, and you have to mention it in the technical specification as well as your drawings, that how puddling is to be done. Right now we have kept it uniformly. Okay, so floors are now created. This is also done. I will go to the base. I will select the joints. Will assign the restraints. Right now it is pinned. I will make it fixed. So now fixed joints are created at the base floor. And here you can see one additional grid is generated in between. In this grid, I can draw the beams where the staircase is going to come. Right now, there is no planning. That's why I have not modeled the beam. And it is a reference plane. That's why you can see the column is directly modeled as one element. It is not dividing at this element. So reference plane is necessary for creating multi-floor or this staircase beam, which is not dividing the floor, but you want to model something there. So this is the 10th floor. We again came to this point. Now in this case, you may think that I want to, model the column in a different direction in the center. What is that? So that also you can choose, like this is the option that you want to convert it into different way. So let's see if it is possible or not possible. So rotation, you can see right now angle degree numbers 1. So will it help you or not help you? You need to check that particular thing. So I'm not deleting the original object right now. So you can see the both objects are rotated by 90-degree angle. Okay. So you can do it directly that I just select one option. And, one of the columns, give it 90-degree. So you have to specify the center. Right now it is 0, 0. That's so somewhere the column has got created, but you are not able to see. Let's say mm, so rotate the local axis wherever it is applicable. Mm. So it is now rotated, right? So in individual objects also you can rotate it. That is what I just wanted to show you. So delete original object as I have selected. So you can see two different directions. It is generated. Generally, the columns never project outside the building like this. So, it is preferred to have these rotated in these directions. This column, if it is in this direction, then it will be shifted inside offset. So that offsetting you have to give. So face has to be straight. So all these things will happen once you model a real building in which these columns that I have shown as projecting outside will not happen. So face of the beam and face of the column will meet at the perimeter. So that way that much offset has to be given to each column, right? That you can do it initially or otherwise you can also shift later on wherever you want to do it. So XY direction you can shift it. Radially orientation you can shift it. So that way you can shift the columns offset initially or later on as well. So this way right now the model is generated. And I have just informed you that how to create a realistic model at the perimeter, also inside, by giving the right offsets as per the architectural drawing. You have to generate that model based on the architectural drawing. That is your job, not the architect's job. but they will also suggest if you have not taken it correctly. Okay, so this model is generated. Now I have defined everything, modeled everything for a column beam system, RCC frame system, having response reduction factors 5, spatial moment resisting frames. I have yet not modeled any secondary beam. So to model the secondary beam, what to do for this? So this is the two-way slab right now. So I want to convert it into one-way slab distribution. Then what I can do is I can divide this a 5 meter span in you know let's say half. So what I can do is select one like this and replicate it in linear direction. So I can also use I will take out this option. So I will choose the point here. So snap option is available. So I can also choose the center. So it is giving minus 2.5. Apply. You can see a secondary beam is created. Right now, to call it is a secondary beam, you have to also understand the sizes of it. So if it is of the same size, I will not release at the ends. But if it is of a half size, I will release at the ends. So you have to be very cautious where you are releasing. People say it is a secondary beam and then they release everything because saying that it will crack. Now, if this is cracking, then your main beam stiffness will also, you know, effective length will also increase. So that way you have to design considering all those things. So right now, so you can define it as a secondary beam by either releasing it or by keeping it as it is. If you do that, in this particular case, what will happen? The slab is full. So it will take as a two-way distribution. Then what you have to do, again, you have to model this slab, but it will take grid by grid, not anything less than that. So, so this option is not working on this directly, but let us see if it is selecting these points. No, it will take full day to model it. So you can take this option and select the points. So as you can see, these two options are not correct to model this slab. That's why it is always better, you know, I always choose this option to model any particular slab that can be behaving independently, not acting together. Your slab modeling also should change if there is a secondary beam for it. Now, Okay, so this is the slab arrangement that has been there. Property modifier is none. So you can add as 0.5. If you make it as an opening and click OK, what will happen that this will act as an opening and this will act as a slab. So as such, you cannot model. You can also call it differently, but if you select it and delete it, it will become a slab that way. So right now, there is no secondary beam modeling I have done. So I'll go back to original model. So I'll have to do for each floor. So what I will do, I'll delete this. Let me see up to what floors this is modeled. It is not modeled on any floor, so I'll model it in all floors. No, in one story only because I cannot do that because of that alignment. So what I can do is I can select this all stories. All stories are selected. I can edit and replicate. Okay. It is model again the same way. Now going into the next part, when the full model is created along with the supports, infill wall is not modeled here. Staircase is not modeled here. Lift core, lift shaft is not modeled here in this particular arrangement. Now, if you want to do that, and if you want to create a lift arrangement, let's say in the this particular area, so what you can do is you take this option and call it as opening, and select this particular total arrangement. 7 meters is too big. So right now I have modeled this part as opening. So this is 5 by 2.4 meter. So now I can go to the stack arrangement. I can select the lifts in this arrangement, and I have to now take center to center distance. Okay, now center to center distance is 5 meter. So 300 minus 5 minus 300 I have to do. Then 5 meter minus 300 and 300, 600 is 4.4 meter. Okay, so 4.4 divided by 2 will be 2.2. So core height is let's say in ly direction, it is LX we will see first. So inside is 3.3. I will make it as 2.2. Number is 4 is 2. Now other direction is 2.4. So from that, I want to take inner to inner. So total is 2.4. From that, I will minus 600. So it will give me 1.8 meter as the core size. Wall thickness is all 300. I will take as it is. Opening height and opening width is already mentioned. So this you will see whether it is exactly matching or not. So you can create a calculation for this before putting it here. Now I want to rotate by 90 degree. It is rotated and I am trying to fix here. So midpoint is this. This is how it will look, and 3D model we will see. You can see the opening is on the floor side. So rightly we have modeled this particular arrangement, or what you can do is you can select this much area, show selected objects only, and in this you can do 3D. You can see that here the shear wall is made correctly, placed properly. And in this you can delete all the columns that are created on this side. You deleted the columns also. Right, so there are no columns now. Now show all objects. Columns are deleted. The shear wall is placed centrally like this. There is an opening that I had modeled, and now I have created a shear wall there. But on the top floor, only on the top floor where the loading I have to apply, I will delete this opening. So I want it to act as a slab, so I can apply 15 kilonewton per meter square in this particular area only. Okay. So for that also, I will have to divide the slab in this particular joint. So either you can model it separately or you can then tweak accordingly. So below floors, it is okay. So this way, centrally the lift core has been placed, and this is how the arrangement is created. This can be further updated as per the architectural drawing or the, that's offsetting of the columns. Now I will go to the plan, bottom story. What I had created for the shear wall, okay. I have to take it as a fixed connection, not as a pin connection. So that way I will again check if all the supports are fixed or pinned or not. So all support positions are fixed now, and the model is generated for further evaluation. Now what manual analysis you have to do for this is you have to now check how much force the core is taking and how much force the columns or the frame is taking, and what is the stiffness of this core with respect to other vertical elements. So how much force will come to the core, how much force will come to the columns, and this is a dual frame system you have to design. So as explained you previously also, you have to estimate in each particular direction. So this wall and this wall is in the y direction. These two walls are in the x direction. Sorry, three walls in y direction, two walls in x direction. So they will participate in particular direction only. You have to consider that and then find the stiffnesses of the wall and the column and how much distribution is required for the slab. Yeah, so network got disconnected in between. So we'll continue again.
Okay. Okay, sir.
Yeah, so this semi-rigid and rigid diaphragm, when your slab is continuous, they are, spanning the lateral force resisting system from one point to the other point. Okay, then that is part of lateral load resisting system. Then it is a rigid diaphragm. When it is not able to take part in the lateral load resistance, then either don't model it as a diaphragm like Mumfty slab or a small portion of the slab in the floor, and semi-rigid diaphragm when it is a flexible and you cannot understand whether it will act as a diaphragm or not. You can give it as a semi-rigid diaphragm or not give a diaphragm. And if you want to design the slab in the software, then you have to give it as a semi-rigid diaphragm. So right now I am giving it as a rigid diaphragm because there is no doubt in the current floor system. So this will act as a this should give it everything as a diaphragm. So I will select object type floors and I will assign shell and there is a diaphragm option in shell D1 apply and OK. So at all floors you will see that diaphragm is got assigned, right, except the base level. So right now you have not modeled the plinth beam. You have not modeled the column up to the bottom of the footing. So that also you can add in this particular model. So right now this is the ground floor level. Now you will go below ground, and then you will, what we say, plain beam you will generate, and that one more level has to be added, which is up to the top of the footing. Your columns have to model up to the top of the footing. Okay, so I am considering right now that there will be a plain beam level, and your column base will reach to the footing top. So that part we have not modeled, you can add into this and you can update the model accordingly. So this is a diaphragm we have assigned. Pier labels now they have already assigned, so we don't have to do it right now in this new software. Old software, it was a different case. Already spandrel they have defined. If something different is there, you can do that. No group we have created. We don't want a section cut right now. Now response spectrum we have to define for IS 1893 2016. So add new function. So I'll take as uh, seismic region 5. So this is 5, 0.36. Building more means more than 200 people are there. So 1.2. Soil type is medium. I have chosen right now. Response reduction factor is 5 for dual system, 4 for the shear wall. Right now it is dual system, so taken as 5. Or else you can also convert it into user defined also, and you can create a vertical response spectrum as well. We'll add it like this. 5% damping. Seismic region, I will take horizontal, seismic horizontal with zone 5. So in zone 5 also you have to do the vertical earthquake as well. So seismic vertical zone 5. So everything is there. Now what you have to do, convert it into user defined. Now take 2.5. Every value you have to copy paste 2.5. Or if you have your own response spectrum you have kept modified in Excel, you can also update it from the you know editor menu. So now you can see it has become a flat graph. So it is okay for 2.5 vertical earthquake. Now you can also add many different, what do we say? Different codes are there, but apart from that, if you want to add from file, So you can add any response spectrum from file, any time history. Also, you can upload it here. So El Centro, if it is there, you can directly select. So you have to give the name. It is El Centro. Period versus value, frequency versus value. So we have period versus value, file name. You have to select the file wherever it is there. Right now, I have not downloaded it anywhere, but let me check if it can detect El Centro. Okay, so right now I have not downloaded it. In previous versions, it is available. So it is available on website. You can upload it from here. Then you will get a graph. You can view that file and then you can click OK if it is found correct to you. So that way you can upload the time history as well and modify the spectrum or delete the spectrum option is there. Now user also option is there. So add new function for the user directly you can put. Also for sinusoidal waves, you can also put anything. So this is now the response spectrum. It is okay to go ahead. Now, if you go to time history, again, there are various options from file. You can upload the time history. From previous, you can upload the response spectrum. Time history is to be uploaded from here. Okay, so add new function, then you can give the read the time history, update these points, browse, and then you have to correctly input the time history from here. So sine function, cosine function, sawtooth profile, triangular blast loading, user periodic loading, match to response spectrum. You can generate the time history. So you can say this is time history matching to your response spectrum. Time domain, frequency domain, it will give two different things. So horizontal response spectrum, I will match to G. Is in G units, okay, not in millimeter, centimeter response spectrum. And match time history. So you can see match time history generated. So plot the match time history. So this is your response spectrum and plot match time history only. So this is the time history generated with respect to your response spectrum and make it okay. So time history is also generated. So ramp I don't want. This also I don't want. Okay. So two functions and time history you have uploaded. Now next part is to give the load patterns. Now dead load, live load. Another is your super dead load. Now in super dead load, you have to tag it as a floor finish. Then you have to take it as your super dead load as the walls. Then your super dead load for parapet. So I make it this way. You can do it whatever way you want to do it. Then super dead load for floor finish, walls, parapet. Then any other category if available in super dead load case, then you can put like landscaping is also there, or you can say waterproofing. So right now landscaping is not there, so I'm not adding it. So that way your super dead load case is generated. Now there is a live load option. Now live load, And so lift is your live load, right? Elevator load is your live load or not? So that I wanted to know from you whether elevator load is live load or not a live load.
Yes, sir. Live load.
Going live, you can define it as a elevator. Now, water tank load is a live load or not a live load? Whatever the water tank is there, so water load will be a live load or it will be a dead load.
I
Firefighting tank is also there.
mhm. I think
So
dead load.
the water load is a dead load. It may be empty also, right?
Yes, sir. Yes, sir. Okay, live load.
So tank may be empty or it may be full depending on that. So water load you can also add. So this way, sorry, this is a elevator, so it should be tagged as a live load. Modify. This is also live load. Modify. So in this is the human load you have already considered. So I can say the human dead load. Sorry, human live load. And these are the other live loads. So category wise, I have made it. Now next is your, waterproofing also considered, and multi-floor, if it is there, what load is coming onto it, you can also add as dead load and live load. And right now there is no multi. Staircase also you can separate it out and call it as a super dead load. So I also take staircase as separate if it is there. Because you're not modeled, so you have to give the loading of staircase as well. Now super dead load and your live is also staircase. So that way, category wise, you can keep on adding, and you can also at the end check whether whatever the load is applied is correct, and you can use it for manual analysis. So this categorization actually helps in that particular way. Now I will add earthquake X. It will be as per IS 1893/2016. Add new load, modify the lateral load. So I will delete eccentricity. If I am giving the eccentricity in response spectrum case, now I will not give any eccentricity here. Importance factor 1.2. Now the time period formula, right now I'm taking approximate rather than that. You have to estimate as per IS 1893. The time period formula is given for the building with shear wall, without shear wall. Now this is a dual system. So what time period will you take for this building? That is my question to you. This is a dual wall system. So should it be taken as 0.09 H upon root of D or the shear wall time period? So as per the code, we will evaluate later once we go into the code of it. So right now I'm taking it as a bare frame as everything is bare. No modeling is been done for the considering infills. So right now I'm considering everything as a bare frame. That's why I am taking as a bare frame time period. Or I can take as a program calculated. So right now let us take off program calculated time period. Response spectrum phi has been considered. Now earthquake in Y. So you can also generate Z earthquake also, but we don't want three-dimensional earthquake right now. Right now, everything is now program calculated. Wind in X direction. So now exposure extends from the diaphragm we are taking. You have to give the right values of coefficient. Wind speed is 47 in Mumbai. Terrain category, I can choose importance factor, cyclonic 1.15, risk factor, topography factor, include the parapet height of 1.2 meters, and okay. Same for Y. So I can just define lateral load, modify load, and I can just add new load here. So these values have to be correctly put for this region. Now, once we are ready with the loading, now what I can do, create a mass source. In the mass source, I will give the load patterns. One is the dead load, one is super dead load. There are multiple loads here, but I don't think so. So again, I have to be very careful in selecting the SD first. So I go like this. That's why it is easy for me, but some people may get confused. So you have to be. So all are one as per this. Now live load is 0.25 because live load is not more than 3 km/meter square. Now elevator, I can take it as 0.25. Water, I may take it as 0.5. Live load staircase 0.25. Right. So include vertical mass if you want to do the vertical earthquake as well. Now I have an option. I can directly give the center of mass. I can directly shift from these values, or I can do the analysis, find out the CMCR, and then do the other things. So I can directly shift CMCR if I have calculated it with me manually. Okay. So mass source one that has been defined. Okay. Now P delta options, iterative based, it will be 1.2. So all dead load you can select first. And live load at 0.5. Okay. So P delta options, preset P delta option you have already given. Small P delta, not capital P delta, you have not given that. So you have to check whether your frame is a sway frame or not a sway frame. All those things take part in it, and mostly it is a sway frame. So your P capital delta will also come into picture. Now load patterns I had defined, and load cases I will generate. Wind, earthquake, all those are generated. I will create a response spectrum load case. RSM X. On nonlinear static stage model response spectrum time history, everything can be defined here. I have taken as response spectrum. Now this is a program determined or user determined. Okay. Mass source already taken, analysis model. Now in which direction I am considering? U1 is the X direction. This is horizontal axis, horizontal direction earthquake in X. Scale factor is already there. It is a model. I will take SRSS method and 0 for all diaphragm eccentricity. Right now, I am not modeling any eccentricity because I have not estimated it. Damping is 0.05%. So when there is a mode combination, you use CQC. That is correct option. Modify oblique showcase, then I will make it as a response spectrum X and Y. So this will become U2. Rest all things remain the same. Okay. Add copy of the case I had to do. So RSM X. This U1 will become U1. So RSM X and RSM Y. So I can see the load case tree, that is the dead load, live load, model in RSMX, RSMY, floor finish, linear static, all load cases are there. Okay. Now in the eigen load case, model eigen load case. Now either mostly people in high-rise buildings are using the RIDS analysis for more of the reason that RIDS is giving you the better response. And whenever you are going more than 20 stories, all are using RIDS only. So if I use RIDS, then preset P delta is there. I will have to add load patterns in that acceleration UX. I will add, and UY also I will add. Now number of modes will become, let's say now I am taking eigen. So this is acceleration UX, or let's say I do it, I delete it. Now, how many modes per story? 3 modes are there. There are 10 stories, 10 into 3, 30. So minimum 30 modes have to be assigned here. So this was in advanced case that is not required when we are doing eigen case. Now we have gone with the load patterns. We have gone with the load cases. Now rest is the default design. Convert to editable. All load cases are defined. Okay. So save the model. Now only part left is now wherever the every floor is there, you have to assign the loads. That is dead load, live load, and all those things you need to add. So over the lift, I will take 10 kilonewton per meter square area. If there is a podium, I will take 15 kilonewton per meter square. If there is a car parking, I will take 5 kilonewton per meter square. And ramp on which the car is going, that also 5 kilonewton per meter square. Loading I will take. Wherever the water tank is there, I will take density of 10 kilonewton per meter cube multiplied by the height. So it is 15 kilonewton per meter square for 1.5 meter height of the water. So at stilt floor or the refuge floor at 7th or the 8th floor, I will have to take water tank on it, firefighting tank. That firefighting tank area has to be defined by the architect. where the tank is going to be, and that area I will apply the water load, right? And on the OHT also I will create columns or whatever the arrangement is there, slab, beam, column arrangement, and apply the water load on OHT as well. If there are the solar coming on the roof of the building, I will add the solar loading as well. If there is any equipment in the office buildings, they require some equipments. So I will take 10 kilonewton per meter square in the equipment area or the server area uh, that way. So loading has to be now applied. Model has been generated. And once the loading is applied, modeling is generated, you have to go to analyze option. First check model, set active degrees of freedom. This is a 3D model, so full 3D. If it is a 2D frame, you have to select that option. Then what load cases you want to run, you can select it from here. Important is you select calculate diaphragm, center of rigidity and center of mass. This option has to be ticked, and then you can run now and then check that where the CM and CR is there. Once you get CM and CR, you have to again go to load cases and go to response spectrum case and diaphragm eccentricity. You have to add for all the diaphragms. 10 diaphragms are there. You give the eccentricity each floor wise. So you refer the another session uploaded on my YouTube channel for center of mass and rigidity, how we have done that. So am I audible?
Yes, sir. Yes, sir.
Yeah. So you have to see the second session on center of mass and rigidity, how we have applied it and how we have done it. So next part will be covered in that video that I have shared on my YouTube channel. So this video is general video, so I will also upload on my YouTube channel. You can also go through that there as well. So
Right, sir.
once those things are available, once you have analyzed everything, now next part is the meshing. So we are using auto meshing in the floors if you are designing, auto meshing in the walls. So meshing I will cover separately into this. So for analysis, you have to do the meshing as well. However, this auto meshing is good option and it is not giving you, separate results from previous models. So you can depend on auto meshing and choose accordingly. So 2 by 2, 1 by 1 meshing you can choose, or you can depend on auto meshing tool option of the ETABS software till the geometry is not complex. For routine cases, it is very well to be used, like shear wall and the slabs. It is okay to directly use it for buildings. And you can see all the responses in the next tabs. So once we have run the analysis, then we will go more in the display and design option in the next session that we have on this. So I have uploaded the drawings on files, 15-story building of building that is having only the columns. No shear wall is there. And this type of building has to be generated by you in this week. This is what the expectation is there. So in next week, we can do the analysis of that building and then go ahead in design of that particular portions.
Yes, sir.
So that is it for today's session.
Sir, as we can see, there are so many things involved in it. So if I want to go into details of these things, uh, which sources should I refer in between so that I can read it by myself as well?
Means regarding what?
Regarding these load cases, load patterns, this spectrum analysis, etc.
So you
Response
can
spectrum.
give your queries with respect to that this lecture in MS Teams or on YouTube. I'll respond to all the queries
Okay, sir.
that you have.
Okay. So also regarding the wind load generation, we
Yeah,
have
all
not.
that you can
We have,
ask
Mhm.
any query in that. Yeah.
Okay, okay. Basically, we have not seen that in manual the wind load. How the wind load can be calculated and applied manually to each story of the building. So, are we going to see that, or do we need to solve it by ourselves first, then
As such,
put
I
the
would request you to solve it first by yourself, and then we can check the
Mhm,
software results. Otherwise, we will do it, then how to check it, we will not know.
mhm. Yes, sir.
So we should first estimate the earthquake forces manually and wind forces manually, and then check it with the software, how it is actually coming. So once this manual analysis in gravity case is completed, then I
Mhm,
can ask you to go for the lateral forces, but yet not many have attempted to do any gravity analysis. That's why uh, I'm not pushing for the lateral forces as well, but you have to do for lateral cases, manual analysis, gravity load cases, and finally for each load case we will check with the software.
mhm. Okay, sir. Okay.
Yeah.
I have basically taken two-story building first for manual analysis. I have calculated the column forces, the final reaction is basically, and I have taken uh, know, the frames from each side basically for the calculation of the reactions, column reactions. Now I am moving forward for the bending moments and the diagrams, bending moment diagrams. So it will take me almost 2 days basically to solve all these. Then I'm going to share that to you, sir.
Yeah, yeah, you go ahead. You can take this full month because next month end we will be completing the course. So we have 1.5 month more for manual
Mm,
analysis,
sure, sir.
right? So by the end of the course, we should be able to compare manual and the software results.
Okay, sir.
Yeah.
Thank you, sir.
Okay.
Okay, sir.
Okay.
Thank you.
Bye. Thank you.
Bye, sir.